Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hey folks, hi everyone. I'm Greg, and so this is, with Heidi, and we have Design and Develop SQL Solutions Like a Pro. This is part of Data Days for 2026 and all about getting certified for SQL and AI. Now, first up, I'm Greg. I'm a data platform MVP and part of the Microsoft Regional Director Program and based in Melbourne in Australia. I've got contact details there. So don't be a stranger, reach out and say hi at some stage. And Heidi.
Hey everyone, I'm also a data platform MVP, super excited to get renewed for another year. I'm also in Australia and today I'm at home in South Australia. I've been working with data for, what are we now, 10-ish years. And before that, I was a software developer. So I come from a coding world, but I'm loving being in the data space these days, and I wouldn't have it any other way. There's always something new, and I'm excited to be talking to you today about all things Data Days, SQL, community. So let's get into it. We've got 60 days of data and AI, but the fun does not stop here with the Data Days community. So go check out that aka.ms link for Data Days. You'll find there's things like this where we're doing DP-800 sessions and SQL and AI. There's ones where we're doing DP-600 and 700 and focusing on more of the fabric space. And there's also the monthly days. So within those Data Days, make sure you check them out. They're in multiple time zones, so you can't miss it. We've even got it in multiple languages. I think there's one in Portuguese coming up. So I'm super excited for that for everyone around the world. And the whole point of attending these is to get certified. Why not? Now, the thing with getting certified, you can get certifications because you just want to challenge yourself with different learning, but you might want to get certified to help you with your next job. And the great thing about attending sessions like today is there's always voucher opportunities. So if you're not someone who's got a lot of money you can shell out on these things, or you don't have a company that's going to be able to support you for that, have a look and attend these sessions, and you can see the little bar going across. There's free vouchers. So make sure you look at those to try and help you on your certification journey. And look at the study guides. We're going to take you through all the stuff, but make sure you get every help that you can. Now, SQL AI Promptathon, because, we're all about AI at the moment. No, we're not mentioning Copilot in this one. But with AI Promptathon, it's your opportunity to demonstrate your skills to the world. Now, I know a lot of people are thinking, is it for me? Is it not for me? Give it a go. You're never going to know unless you give it a go. Got to be in it to win it, as they say. So make sure you get your phone out, scan that QR code, join the AI Promptathon. And if it's not for you, join the next challenge. I know we've had data viz challenges, notebook challenges, ETL challenges, ontology challenges. So now we've got the SQL AI Promptathon. Or just check out what people submit, because it's so cool to see the ideas people come up with. Love this slide. It reminds me of Henry the Owl when Fabric has a little bit of a moment. It wants to take a day off. But there is the Data Days hotline, 8 a.m. Pacific time, Wednesday, 23rd. I'm thinking about being in the future in Australia. 22nd of July. Get those questions answered live. And I'm always amazed that people look at these and go, I'm not going to get my question answered. You'd be surprised. I've been on a live stream with hundreds of people before. I put my question in and suddenly I've got help from someone around the world. So if that burning question, why not take it to the Data Days hotline? You can see there, we've got SQL, we've got Fabric, we've got Power BI, all things data, data, insights, action. That's what we're all about. But Greg, what else we got in the schedule?
There's so much. So this is so wonderful at the moment. We've got many things to do with DP-800 first up. So there are basically in 2 time zones. So this is, of course, the cool kids who would be in the APAC time zone. But there's also ones that are more North American friendly or Europe. And so the EMEA time zone has it. And so each of the sessions is available in both. So if you, for some reason, don't manage to get to our local one here, you might be able to attend the other one as well. But it's not just all DP-800, even though that's the thing that we're sort of focusing on at the moment. There's also a whole lot of just fun sessions. And so notice there's a bunch of them that are just about growing your career. And so building connections, we've got grow your career. And there's a bunch of things that are to do with community. So we've got a whole lot of things about how to get involved in the community. And as I said, a whole lot of things about building up your career, but also things that are interesting from a sense of achievement point of view. I particularly liked the look of the session that had from I'm just getting started to I made this. And so that's awesome. And finally, note at the bottom, there's also one which is really, if you're not sort of terribly used to doing exams and things like that, there is a session that just really walks you through what happens on exam day, what you're going to expect, and really importantly, what is it you need to do to be able to get through and pass these sort of exams. Now, importantly, it's not just us today. So we have wonderful moderators who are being involved with the thing today. And so I'd really encourage you, don't just sit back and watch what's going on. Put your questions into the chat and see what we can get answered. Most of the things will get handled by these wonderful people, and anything that's sort of super interesting for the whole group, no doubt they'll highlight and let us know about it, and we can do it live as well. But we've got Ilga. Ilga's based here as a fellow Australian and a data platform MVP, and also a Fabric super user. And Indira, one of our buddies from Auckland, New Zealand, across the ditch. And also Dean, who a bit further along. So Dean's based in Atlanta in the USA. So as I said, talk to all of them during the session, get your questions answered. Now, what we're going to go through today, obviously an overview of what you need to know to get through DP-800. I must admit, when I did it myself, it was in the pre-release or beta phase, and so I was a little less prepared than what you need to be. So the thing is, you can now, there are so many resources that are available for this. You can be really well prepared to take this exam. And the sections that we'll go through are the 3 main areas that are part of the exam, and importantly, the AI code that's part of it as well. Now, if you look at the role that's involved here, this is not just a SQL Server role. So it's SQL related. Now, that's actually SQL in both on-premises with SQL Server, or maybe in virtual machines, but it's also the Azure SQL offerings, importantly. And in addition to that, nowadays we have SQL databases as part of Fabric as well. Now, the key skills that you need to have here are still the same things that you'd normally have if you're working with SQL Server in any other environment. Those things are still important. You also, in addition to that, though, need to be comfortable with things like continuous integration, continuous deployment, and integrating with GitHub. And finally, of course, this is not just a SQL Server exam. This is very much dealing with the fact that you may have AI-related issues that you need to deal with. And so this is a developer associate, but it's a SQL AI developer associate. Now, the sections of this that you need to work through, there are 3 domains that are part of this. And so the first is designing and developing database solutions. This is all the core stuff that if you've worked with the product for many years, you already will know how to do that. Or if you haven't worked with the product for very long, these are core things you have to know anyway just to work with the standard SQL Server product. And so this is the building out schemas, building tables, indexes, constraints, and of course the programmability options around procedures and functions and triggers and so on. And this is 35 to 40% of the exam. So note that's a sizable chunk. And when the authors are building out the questions, they're all building them out in this proportion. So it's not like you're going to go and do the exam and suddenly you'll get just 10% of the questions on this. You can pretty reliably nowadays estimate that you will get about a third of the exam on this. The second part of this is the data security and compliance section. And note that it's sizable as well. I think if anything I've heard from people who have been trying to take our DP-800, most of whom have been fairly successful, but the thing that I think surprised a bunch of them really was some of the focus also, as I said, around SQL projects. And so projects and continuous integration and deployment, and basically Azure integration. So those things are all super important as part of this. And finally, this is an AI-based exam as well. And this is something I'd encourage you not to underestimate. I have heard that it is probably almost possible to pass this exam without much background in the AI sections of it, but I would not suggest you try and do that. Note this is, again, about a third of the exam. And so this is a pretty big deal in the exam. And so we look here at embeddings and vector search and hybrid search and RAG patterns and so on. These are things you need to be comfortable with. And one of the things I've come across when I started talking about this with some of our own courseware and things is I have people come back and say, oh, well, our company's not doing any of that in SQL Server as yet. And they think, oh, it'll be years before people start trying to add this to the database. But that's not how it works. In fact, what I'm finding that's sort of really interesting at the moment is there's actually a CEO-driven interest in this. I've had a number of clients who tell me that even in their technical areas, they hadn't started working on this, but then their CEO has gone to some conference, found a whole lot of information about this sort of thing, and then come back asking lots of questions about what are we going to do or how does this fit. This is really interesting because it's normally the technical people who've been driving these discussions, but now it's people like the CEOs. And what's really important is that when that discussion happens, it's super important that you know the answers to a level that you can have a sensible discussion with them. Because if your bosses and people come back and want to have a discussion about how the AI areas are going to fit into what you're doing, if you can't contribute to those discussions, you end up sidelined, and you really, really don't want to be sidelined. So anyway, we'll wander through each of these areas and have a look at it. So first up, Heidi, tell us about the first one.
Yeah, we got design and implement database objects as our first one. And we're talking about things, everything from tables, indexes, constraints, data types, whether it's JSON columns. Yes, we do put JSON columns in our SQL databases, and we're going to go across. We're going to talk about SQL Server. We're going to talk about Azure SQL. We're also going to talk about Fabric SQL. And it's important to know that when we're talking about those SQL Server platform choices, as we say, you've got SQL Server on-prem, where it all started, that box product, and a lot of companies are still using it. I think my first experience with SQL was 2000, SQL 2000. And cool, put what you've experienced in the chat, because I'm keen to see, I see there's people from all over the world. I'm keen to see what versions people are working with as well. So you've got that SQL Server on-prem, and it has AI capability, so it's not to be forgotten. So if you are on-prem, there is AI capability available to you. Then we've got things like Docker and Kubernetes, and that's where we're doing a containerized solution of Fabric. It's very common in the not e-commerce world, but the e-gamer space, as well as companies that are doing stocks and trading. And so with that, we've got containerized solutions, whether it's in Azure or on your own local development machine as an area where you can do development. We've got Azure SQL DB MI. So Azure SQL DB, our PaaS-based solution, and then Azure SQL Managed Instance, which allows us to have that full instance level experience, but in Azure with high availability. And the features just keep getting better and better with Managed Instance. And then we've got Fabric SQL, which is one of the more newer ones that's come out. I think that's probably about a year old now. But with Fabric SQL, it gives us that integration with the underlying OneLake. And we can use Copilot, but we can also do AI ready in the analytics space or the operational database space, because now in Fabric, you of course can do Fabric apps and things. So we can do operational databases as well. So it's important to know when you are going to work with these database technologies is which platform. Are you going to go cloud? Are you going to go on-prem? Are you going with PaaS? Are you going with a SaaS offering? Once you've got that decision down packed, we're working in our table design space. So within the database now, we've got to look at what are the data types that we're going to choose. And it's important to right size those data types. You don't want to have more storage than you need. Doesn't mean your database isn't going to grow over time, but you want to make decisions like, should I be picking an int or a big int? Should I be picking date time 2 or date time? It really depends on what you're doing. And I know in this global society that we have, it's oftentimes where I'll use date time 2 because I want to put things like time zones in it as well. Not everything's UTC. We've got decimals and we've got float. That's an important one to know what the precision's going to be, because you don't want to say, I'm going to use decimal and set a precision not aligned to your data. Not only do we talk about data types, but you've got to make sure understand keys. And one of the key ones there is the primary key, the one that makes sure you've got something that is unique and identifiable and narrow for your database. It could still be a GUID. That does happen, especially if you're using software solutions, but it's got to be unique. And we talk about specialized table types because we like to have things that are special within our world in data. And so we've got in-memory OLTP. That's where you can have large amounts of data readily accessible, fast off the bat. You can get 30 times faster OLTP, native compilation there of stored procedures. We've got temporal. Temporal is very common when you want to do versioning. You don't necessarily have to build it into your data management and movement strategy. You can build it into the underlying table so that it's done for you. And then at any point in time, you can do a bit of time travel. We've got external, because sometimes our data lives somewhere else. It might be living in blob storage. It might be living in S3. It may even be in Oracle. Yep, still better together even with the competitors. So then we've got ledger. Ledger is super common in financial and banking institutions where you want evidence that your data is basically been updatable and append only and tamper evidence. So if you need to know how the data changed, when the data changed, who the changed data, ledger is another one to look at. And one of the lesser common ones in a lot of spaces, but also really, really crucial when you're doing things like neural networks and you're doing relationship mapping is the graph one, because we're talking about nodes, edges, and we're doing matches. This is really cool to do 360 views on your data. And I see a lot of people these days doing neural networks across different data types and data sets. And you see it even more prevalent now with ontology coming in to our data space. But once we've gone through table types, we're on to indexing. Indexing, one of the I feel like it's one of those hidden gems, but also it's like a dark art. It's something you really, once you get into it, you're going all in on performance and optimization with indexing. And I love the more query intelligent features that Microsoft's brought in. So if you're not someone who's super familiar with indexing, Microsoft has a little bit of smarts in the background to make sure your data is optimal for whether it's read or write. But you've got the different types and you need to be able to understand which one is going to be appropriate for the outcome that you need, and can you do them in combinations? So we've got clustered. Now you've got to remember you can only have one clustered index per table because that's defining the physical sort order on the table. But then we can also introduce non-clustered. So you might do things, might do non-clustered where you're doing things like lookups, where you say this is the primary key to do the lookup on, but include these other ones for quick result set coming back. We've got column store. Data can often be very column-based, especially if you're working in analytical worlds. I know I come from business intelligence as my data background with data. So I often look at things like column store because the column proportional values is important to my workloads. We've got filtered indexes. That's where if you're going to be doing those where clauses and predicates, that's where filtered indexes is going to really shine. It's great for sparse columns, active records only. It's not as prevalent as the other ones, but it's still an important one to know about. Full text, AI people, that's your world. Anything that you're going to be using natural language searches across, you want to be looking at full text search for sure. And then not to miss anything out, we've got the JSON one as well, because a lot of the payloads when you're working with web developers are going to be JSON payloads. So JSON indexing is super important, but that's very, very, very new. You see the little tag, it's 2025 and beyond. So it's only in the most recent edition. But given that this exam, the DP-800, has a focus on SQL and AI, it will be more towards that 2025 feature set and above when it comes to this stuff. And vector indexes, that's the other one. So when you're doing vector embedding, you're designing your data sets to be crucially responsive for your LLMs, you're going to want to look at doing some vector indexing there to make sure that you can do those nearest neighbor searches as fast as possible. And make sure that anytime you're looking at your where clauses, your join clauses, your order clauses, those are the things that you want to make sure you've got indexes for. But don't do all of them. Just because you can doesn't mean you should. Just because you can put as many indexes as you like doesn't mean you should. Don't go putting like 80 indexes on the one table. SQL can handle it, but it's not going to be the most performant. And then we've got, now that we've talked about our indexes, we've got our table, we've got our database, what about constraints? We want to make sure that we've got smart referential integrity. Someone's not putting data into our database that doesn't align across the board. So we've got our primary key. That's what we talked about earlier, unique value. Foreign key is where you're linking to another table, but you want to make sure when you're inserting values in, if there's a foreign key relationship to another data set, it's the correct value. That could be lookups, it could be dimensional data, it could be all sorts of things, but you want to be able to do that so you can make sure that you're not inserting bad data into your database. Unique is if you wanted to make sure that every value you put is unique. The check constraint, you might have some data validation. We always say, as far left as, as far upstream as possible and as far downstream as necessary. I always get the Roach's maximum around the wrong way, but basically do it as early in the design as possible, not right at the end with your workload. Check constraints there allows you to do some of those data quality checks at the database level so you're getting the right type of data in your data set. And default, always good in case you want to make sure you've got, say, a new identity. If you don't have a unique key for your data, then why not use identity inserts? Why not use identities to make sure that you've got that unique value no matter what? And with that, JSON columns, you've got to make sure with JSON columns that you know how to do things like JSON query the data in a way that gets you the elements and attributes for that JSON, or you may want to return the array aspect. So understanding JSON query is really important, understanding JSON value and open JSON to be able to work with those JSON values in the database. And those are really fun. I love doing them when I'm working with web dev. I'll use JSON columns in a database to work with web developers so that I can quickly query it and then tell them, hey, when you're doing the API build out, here's how you're going to access the data in the most efficient way possible. And then sequencing and partitioning. There's just more and more with this sequencing versus identity. So you've got to look at the feature and what's the most important. So if we're looking at sequencing, we're creating a incremental value for our data set. So that could be things like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or it could be a sequence aligned to another data set that you have and you define it, maybe jumps in data. It's at the database level, but you can share it across tables. So when you want to use a sequence but use it across tables, there was a bit of a strategy a while back when anyone was doing data warehousing. They wanted to have the unique sequence to be universal across the whole database. They didn't want someone to accidentally join two tables that were totally unrelated, so they'd use the sequence. Versus the identity, which is more at the column level per table, you can only insert into that. You're not doing it any other way. The cycling is important. You can, of course, do identity insert as well. So if you needed to reset your data, then you absolutely can just bulk insert. I do that a lot when I go between my development, my test, and my production environments with certain data sets. It might be master data sets where I want to make sure the index is that identity is the same across the board. And you want to look at making sure you understand partition strategies. When do you create the partition? How do you create the partition? What are some of the things you need to know So, what's the scheme? What's the table you're going to add it to? You want to know that you can switch partitions. That's an important one to know when you're working with data loads, is how do you quickly get data into your database, make it a seamless transition. You can often do an insert and then schema switch, and it becomes a partition switch, I should say, becomes live straight away. And you've got the option to do automated data lifecycle management in that space. But now that we've got those core fundamentals of databases, Greg, tell us about programmability objects.
Yeah, well, of course, the things that Heidi's just been talking about cover how we store information in the database. But of course, the database is more than just a storage location for data. So we have, in addition to that, objects that we can build within the database that are programmable objects. And so we'll look at views and stored procedures and user-defined functions and triggers and more. And of course, these allow you to get better code reuse. They're used for security boundaries. And of course, they also can assist with maintainability. But first up, views. It's important to understand the different types of views that we can have in SQL Server. And so this is good core knowledge that hasn't changed in a very long time. And so it's an area you need to understand really quite well. If you look at a standard view, all a standard view effectively is a name that you've given to a select query. It really isn't anything much more than that. So the idea is that rather than writing out a select query in detail all the time, you can go and create a view and then just reference it instead. Now, there's a difference also to understand between Standard Edition and Enterprise Edition of SQL Server in terms of how it works with various things in views. Make sure you understand some of those differences as well. But we also have indexed views, and this is where the difference really comes in. And in many of the database engines, there are things called materialized views. And what this is saying is I'm going to, rather than work out every time I run a query, I'm going to work out what needs to be done. I'm going to pre-calculate the values and store them instead. So an indexed view feels under the covers a bit more like a table. But rather than being a table that gets changed by inserts, updates, deletes, and so on, it's a table that gets changed by the fact that SQL Server detects the fact that the underlying data that the view is based on has changed. And so it needs to rework things out. Now, importantly, that means you can't just do indexed views on anything. There are strict limitations on the types of queries that you can have in indexed views, but very differently to how this works in other engines. In many other database engines, when you have materialized views, you have to force them to get refreshed every now and then. In fact, I've just been doing some Databricks work recently, and there you can either set an auto detection or you can say, here's a schedule where I want this updated. But it's not like that with SQL Server. You don't have a schedule, you don't manually refresh them, and so on. You basically let SQL Server manage the update of the data in the indexed view. One of the requirements for an indexed view, though, is that you must create the view with schema binding. And it's important to understand that one. In particular, what that's really saying is that if you have an object built over the top of some tables and things, and it's done with schema binding, and this could apply to views or index views, you can put that restriction in, and it says, look, I'm not going to let you go changing the tables that these queries are running over the top of. And so the schema binding stops you being able to make certain changes to the underlying tables. But anyway, the main thing with index views is that it gives you a sort of a quick outcome, particularly for aggregation heavy reads, but it does add additional overhead at the time you're doing writes. We also have partition views, and this is where you can't have everything necessarily in the same place. And what you can end up doing is building a petition view that says, get some of the information from here, get more of the information from here, get more of the information from here. And it's effectively a union all across all of those different places that the data is coming from. And there's also a concept of a distributed petition view, and that's where we have things like linked servers involved. But the main thing is just get comfortable with the different types of views and the restrictions that can apply to that. Then we have, of course, stored procedures, and in SQL Server, these are all T-SQL-based ones that we do this in terms of the language, but we can also have still SQL CLR, the common language runtime ones, the .NET ones. And if you're working with SQL Server, understand that you can have SQL CLR ones, but if you're working with Azure SQL Database, for example, that doesn't support that. So know the differences. But the core capabilities of these, we can have input and output values, and as well, the stored procedure can return a return value. Most of the time when people do that, they're using that to return whether it worked or not, effectively, its success or otherwise. Another thing to be aware of is that with the parameters that you're working with, you can also pass in tables nowadays by using table types as the parameters that are passed. Be aware of how dynamic SQL works. And so inside a stored procedure, we often use a stored procedure to be a security boundary. So you're letting someone run some code when they can execute the procedure, that the steps inside the procedure, they can't necessarily execute themselves. So we're giving someone permission to do something that they're not probably able to do with the individual steps. Or it could be just to simplify things for them. But just be aware that if you have dynamic SQL inside there, that breaks that boundary. And so when you execute a procedure and it goes and runs dynamic SQL, that's then done in a different execution context. So it's important to understand that. And the fix that came for that really helps us is a thing called execute as. And so with execute as, you can add to the definition of a procedure. And that says, look, even though someone is running this proc, inside the proc's code, maybe we want the code to run as someone else. A very, very common thing is to say with execute as owner. And so that says that if I own the stored procedure and I let somebody run the stored procedure, all the code inside the procedure runs as though it's me, not as though it's the person who's calling it, and so on. A big issue for stored procedures is still parameter sniffing. SQL Server tries to avoid recompiling all the code all the time. And so what it'll do is it will save the query plans that it's using and then build a hash of those. And when you go to execute code, it does a hash on your query, looks up to see, hey, has this been done before? Is there a procedure already there? And in that case, just run the code again. But one of the problems is it's quite straightforward to build code that would run very differently with different values of parameters. So imagine if I have like a list of values that I'm processing, and when I first compile the procedure, that would only affect 2 or 3 rows. And then I later run the procedure and I'm doing something that would hit millions of rows, then you could get a very, very poor outcome, because maybe it would take the approach that it should have used for 2 or 3 rows and it tries to use that for millions of rows. That's the sort of thing that causes problems with parameter sniffing. And so some of the options that we have around that, at the procedure level, you can say with recompile. But nowadays, on individual statements, we can say option recompile. So you've recognized that this is a statement in the proc that can cause problems. So recompile before you run that statement. Another one you can do is you can also nowadays say optimize for and give it a hint what value to use as part of the optimization rather than the value that's coming in as part of the procedure's parameters. So it's important to get an understanding of how all this works in procedures. In particular, if we mention their design patterns, these are used in standard insert, update, delete operations or CRUD operations. We have ETL pipelines, I mentioned report generation and so on. But as I said, make sure you spend a little bit of time getting your head around how plan caching works. That's really important in this. We also have user-defined functions, and these are sort of a blessing and a curse sometimes, a little bit. And what it is if you look at the most common causes that we often see with performance problems in SQL Server, it's that people have made extensive use of scalar T-SQL functions. And so a scalar T-SQL function is one that returns a single value. So scalar meaning single dimensional, basically. And what happens here is that you have a function that takes a bunch of parameters and just returns a single value back. Now, you might use that in a select or a where clause or in a check constraint. And the issue with this is that when they get executed row by row, which is what's happening if you're doing a select or a where and so on, then that can have a really quite severe performance issue with that. Now, importantly, there are a subtle difference in how you can build scalar functions. So you can build a scalar function that has a series of procedural steps that SQL Server has to follow. The other type of function that you can build is an inline function. And this is one where effectively it ends up being the equivalent of something that could have just been a select statement and so on. And it basically just has a simple return in the definition of the function. Now, they are inlineable functions when you have that sort of thing. Now, they are the sort of ones that in more recent versions of SQL Server, there's been a lot of work to optimize the performance of those. And in many cases, when you have a scalar function and it's causing you some sort of performance problems, you'll find that if you read online and say to people, how do I fix this? There are two options. One is that you unpick the code that's in the function and don't have it in a function at all. Or the other advice you'll get is to turn it into an inline table valued function. And so instead of having it in a select or a where clause, this is something where you would join to it in some way. And the beautiful thing with those is the performance of those is often really, really strong. It works incredibly well. So in many cases, taking scalar functions and turning them into inline table valued functions will fix many, many of these sort of performance issues. But that doesn't apply quite the same to the third category here, which is multi-statement TVFs. And so you can also have table valued functions, but ones that aren't inlineable. So you can't have it effectively like just a single select or whatever that we have in an inlineable one. With a multi-statement one, you declare a table, and inside the function, you insert rows into that table, and then what you do at the end is you return that back. And that's used often for quite complex logic. So these are not inlined, but the beautiful thing with them is that most of the time, that's not so much of an issue because they're not used row by row. They end up being something that can be executed once, often, and then just joined to, and so that works great. The other one to be aware of here are triggers. We have different categories of triggers in SQL Server. So the first are the DML triggers. This is data manipulation language. And these work with insert, update, and delete. And so it says here fire on. I'm not sure I'd exactly say on. This is, they fire after most of the time. So this is a thing that's important to understand about the way triggers work in SQL Server. Your standard triggers, what happens is you make a change to the data, and then once the data change has occurred, and has been written to the transaction log effectively, what then happens is the trigger fires, and then you have an opportunity to do something about it at that point. So you could roll back the change that's occurred, but in addition, you could go off and do additional changes. So for example, if you have a DML trigger, let's say when you insert rows in one table, or maybe a delete, let's say, you could do things like go off and write into an audit table or something like that as part of the trigger. And so the original thing happens, and then the next thing happens. When you have logic that you're implementing in triggers, because of the fact that the change occurs and then the trigger runs, it's important to not use them for things where you could have used constraints. So if I have a constraint that says the value must be between 3 and 10, if I have it as a constraint, when I go to do the insert or the update, it checks that before it does the operation. In the case of it implementing in a trigger, what would happen is I would make the change occurs, and then I'd have to roll back what happened if the values weren't right. So whenever you can, as a design, you want to be trying to do things in constraints rather than doing them in triggers, because the constraints happen beforehand. The other type of trigger here, with DML triggers, we have instead of triggers. And many database engines have a concept of a before trigger. We don't have that one. So we don't have a trigger that runs before the change occurs. But what we can do is instead say, look, instead of doing the standard change, I want you to run this other code instead. So for example, a common thing I've used with this are things like soft deletes. So imagine I have a rows in a table and I don't want people to delete them. I can have a trigger that says, look, whenever somebody goes to delete that row, just set a flag that says is deleted rather than letting them delete the row at all. So we can do all sorts of interesting stuff with that. We also have DDL triggers. Now, DDL triggers happen when we have create, alter, drop. And one of the things to be, again, aware of with these, people talk about using them to prevent certain operations occurring. They don't prevent them, but they have the opportunity to roll them back later. And the information about what's just occurred comes in a chunk of XML. So the XML is called event data, and that one contains the details of the query that's just changed and the change that is trying to occur. It is important to understand there's also no instead of triggers for DDL. So they're all after triggers, where DML triggers have after and instead of. DDL, or data definition language triggers, only have after triggers. I would really like them to have instead of triggers, but that's not a possible thing right now. And finally, we have logon triggers, and these I tend to use fairly sparingly, but we've got code that says when someone logs on, here's some code I want to run. Now, you could use that for various logging operations and things like that, but it's also, the note there, limiting concurrent sessions. You can, in a logon trigger, make a decision that says, I don't want this person to log on now. Maybe it's only certain times of the day I allow them to log on, or only if they're members of a certain group and it's certain times of the day or whatever. So I can make a decision that says, once they've tried to log on, you can just say roll back, and what that will do is it'll log them off again. I don't love that from a security point of view, because what the user is told is they're told they were logged out by the logon trigger. And normally in security, I prefer an arrangement where if you can't log on, the system doesn't tell you why, but it does do that with a logon trigger. The final thing with those is note there isn't a log off trigger. So this is only at the stage of log on. But anyway, so that's this section. Heidi, tell us about advanced T-SQL code.
Yeah, thanks, Greg. We're absolutely going to talk about those advanced T-SQL. And I love the little hints and tips you give out throughout the session. And I love the chat going on here with all the questions. So definitely keep those going for our moderators keeping busy. But one of the big ones in the advanced T-SQL space is windowing is CTEs, I should say, getting ahead of myself. CTEs and correlated queries. So let's start with that one. So with CTEs, they're where you can define data by using the with clause. We create this named data set. It's temporary. It results that only exists for that single execution. So it's not like it's putting it into the database to be reused over and over and over again. The CTE, we can put it with select, we can put it with insert, we can do it with update, and we can do it with delete, but it's not persistent anywhere. So often use it for very temporary situations where you just want to get a data set in a particular structure, work with it, and then it disappears. SQL does let you do recursive CTEs as well. So you can have a CTE that allows you to do recursion and traverse the data. It's really cool to use that when you want to go through and recurse through a number of layers. That might be things like your org charts, your bill of materials, or any tree traversal thing that you have. But don't worry, Microsoft has you covered by making sure there's a max recursion hint that you can have so you don't end up in an infinite loop when you're working with the data. It does default to 100, so make sure if you're going to start using that hint that you set it appropriately for your data. And with CTEs, we can stack them. So we can have a CTE and then we can simply put a comma and have another one and another one and another one. So you see that a lot of times when people go, oh, I need this data set and then I need to break it up into this one and this one and this one, and then I need this final result set. So that's where CTEs can be really handy because you can break that query down into readable named components. So you might see, org chart with manager followed by, different setting on the org chart. We've also got the option there. So with CTEs, temporary, you'll often find people interchange between CTE and temp table. You'll get a point where you want it to be reusable, or it might be from a performance standpoint. So you'll switch from CTE into a temp table. But the other one is the correlated subquery. So with that, we're defining a structure that we can use in an inner query and reach back out to the outer one. So you see it a lot where people are using exists and not exists, so that you want to get one set of data, join it to another one and say, I only want you to give me the result set back where it exists or doesn't exist in this other one, but you need to tell it how to relate that inner query to the outer query. So that's where you're doing the correlated subquery space. And the good news with those is you can have them rewritten or use windowing functions. Just depends on what you're doing. The other one, window functions. These are like one of my favorite things to do. I love it when I'm working with data and I need to do like, oh, look, give me the row number, give me this set of data and just put this row number on it or rank it. Now, the key thing to be aware with row number is no matter what, that is going to be unique. So even if it thinks the two rows are basically the same in an ordering sense, it has to give them unique. So it'll always increment. Whereas rank and dense rank allows you, if they're the same, to give them the same ranking. We've got offset where you've got lead and lag. And sometimes you want to use those to go, the first value or the last value type situation. We've also got aggregate. Aggregate, this is great because windowing functions, by the nature of how they work, they're at that sort of row grouping category. So you're creating aggregates for the rows. So when you're bringing out the rows, people used to do group by and counts and then just have CTs and temp tables. Now you can just be like, I need to select my manager. And while you're at it, for each manager, count the number of employees that report to that manager, or do the average. If we're working with an org chart and financials, we might want to know the average spend for a particular cost center across all the cost centers. So now you can do it. Each row have their own aggregation. And then last but not least is, of course, our distribution. So when you're doing distribution across data and you want to do statistical positioning, you can look at things like the percent rank, percentile, continued. So those are really cool for our statistician world and our data science space. With JSON and XML, it seems like dark arts, but don't get afraid of it. Once you get into JSON and XML, you'll be thankful you understood it. It takes it's a bit of a hurdle. It's a bit of an uphill climb when you're getting started, but it's great once you do get in there. So with JSON functions, when we're looking at JSON path and auto, this is crucial when you're working with data and you don't going to work with APIs. Often you need to send JSON payloads. So you can query your data and have it do a for JSON path or for auto to automatically structure your data in a way that's JSON payload. Then you can give that to your APIs to work with. You've got JSON query, which we talked about earlier. JSON object, JSON array we covered. JSON is a great one to make sure is the data that you're working with in a valid JSON format before you do anything further on it, so that you're not returning errors in your queries. For XML, path on the XML side, very similar to JSON path, allows us to bring back the XML in a format that is appropriate. So we can take columnar data in a SQL database and return it as JSON. We can query it as well. We can go through the elements and attributes of the XML, and we can look at different nodes within that. Open XML, very important there when you're working with just string data. And you go, yep, now that I've got that string is actually XML, cast it to XML, work with the open XML, and then start querying it. And of course, with our indexing and our schema collections that we talked about, you can do that strong typing and validation to make sure that when you are working with XML data in your database, it is, of course, valid and structured correctly. SQL Server 2025 brings us regex and fuzzy matching. I know you would have thought it was in an earlier version because it's been popular for forever and a day, but it took a little bit longer to hit SQL Server than it did the general world. But regex, regular expression, of course, allows us to query the data in a way that we want to find different patterns, whether we want to find where a string is like another string, where we want to replace based on a particular regex pattern. You might be looking at social security numbers and you want to redact the data. Regex replace is a great way to be able to do that as part of your stored procedures and functions. You might want to make sure that it's sargeable as well, so make sure you got that best execution efficiency. With fuzzy string matching, that's great when you're working with data where you want to match it, but it's not going to be a one-to-one match. You want to go as close as possible. Think about matching like names. You've got names, they might be phonetically spelt, they might be spelt a different way. So using the fuzzy matching allows you to get the best possible matching with a little bit of variability to it. So we can look at going, is the distance similar? Are we looking at things like the Levenstein distance function between two strings? Are we looking at it from a SoundX perspective? And you can do all those different ways straight within your SQL now. So you can do that regex pattern match, and you can do that fuzzy match. And you can also do like your exact matching. That hasn't disappeared. That's still there. So you've got all those different capabilities. And we've also got graph. Graph queries is where we're querying those node tables and the edge tables. So think about node tables as storing your entities and edge tables storing your relationship. So then you can query that data to say, oh, I want to know where this person follows another person. You might be looking at data from social media. So follows is an important one there. You might be looking at products and sales and things, or you might be just looking at the relationships between different data. Super popular with the neural network space. And you can also do shortest path. I want to find the data that's related to this other data set, but do it on the shortest path possible. So you're getting those direct node matches versus indirect node matches. You've got try catch for your error handling. Make sure when you're doing that, you are bubbling up your error messages so that you're not just getting things like, yep, unexpected error or an error occurred. You want to make sure the details of the error in the error message are captured and you're doing safe error handling with your code. You may also want to do in your try catch, you might want to abort. If something goes wrong within your transaction, you can abort the transaction and roll it all back and make sure that you're doing your transaction counts and your commits and roll back. By the way, don't forget to do the combination. You don't do a commit without having, you don't do it without having the commit, and don't do it without having your rollback in that query design. And log errors to a table if you want to reuse those errors for something. You might be doing AI and you might encounter an error and you might need to see that and then enhance your database design going forward. So there's all sorts of different options we've got there for queries and error handling. But we've got to talk about AI because this exam has a lot of AI focus.
It does. Well, we said it's basically about a third of the exam. So there are a number of areas that you really need to get comfortable with. The first is that there are AI-powered options in many of the tools and things now. So, for example, in GitHub Copilot, we've got options directly inside there. So you can do the obvious things like, I need to write a query that says this, and have it go and write the SQL query for you. But in addition to that, the thing that can be really interesting if you're doing maintenance work on existing code, you can say, look, I don't understand this, or please explain to me what this code does, and have it go through and explain to you code that you don't understand. When you first start working with this, having it prompt you with code completions almost feels a little bit spooky, but it's really quite useful. And I've found already I've increased the speed at which I can write T-SQL code just by the fact that it generates a whole lot of prompting of what it thinks I'm trying to write. And that's actually really, really good, being able to do that. And the important thing, compared to an external tool, where we have something like, let's say, ChatGPT or something like that, the difference with any of these Copilot options is they are aware of your code without you having to sort of like export a whole lot of definitions and send them up to ChatGPT or something. It's aware of the context in which you're working. And similarly, exactly the same sort of thing is available for Copilot in Fabric. So it has a chat pane where you can chat and write code, and you can help it. You can have it help you with documentation and things like that. It takes natural language questions and generates T-SQL queries. It's interesting the feedback that some of these tools provide. I had one chunk of code the other day that I pushed into one of these, and I said, hey, can you just format this for me? And I gave it a set of formatting rules, and it did the formatting. But what was interesting is it also came back and said, oh, by the way, there's a bug down in line whatever. And it found a bug when it looked at the code while it was doing the formatting and warned me about it. And I was super impressed. This was somebody's code that I was reviewing, and I was starting by formatting it first. And the very first thing it did is tell me about a bug that it found. These tools are impressive. Also, make sure you're aware of Model Context Protocol. And so I would say start by having a look at a thing called the Data API Builder. And that allows you to build an API really very easily just with JSON configuration files that talks to, it can be SQL Server, it can be Postgres and other engines. But importantly, if you're working with SQL Server, you can just enable an option inside the Data Access Builder configuration, and that will generate a SQL MCP server that then has a whole lot of skills that it can execute. And so at the moment, it exposes 6 DML tools, but this will build out and do far more in future. The other thing that I might add that you can just enable easily inside Data API Builder is you can turn on an option, and it will just provide a GraphQL interface into the same code. It's super impressive stuff. And AI workflow integration, this is how are we going to then combine these tools to work through. So you'll either end up using GitHub Copilot or the Copilot options inside SQL Server Management Studio, or inside VS Code is an option there as well. You can have GitHub Copilot connected into that and have it do all of these things for you. We can connect using a SQL MCP server, and that's going to let an AI agent be able to talk to your database. We can use any of these tools to analyze existing chunks of code, and we can also, from governance, use it to enforce decisions or structure. So if you look at the table they've got here on just a decision guide, so they're saying when to use what. So if it's high throughput OLTP with, and they're saying without latch contention, actually it should really be. These are in-memory tables and natively compiled stored procedures. We've got for audit trail and data forensics and compliance, they're saying be aware of ledger tables. For query external storage, you need to look at external tables. I also use that to connect from, say, an Azure SQL database to another Azure SQL database. You can do that. For complex relationships, we've got graph. For reusable read-only access, then views. For complex pattern matching, they're saying the regex functions. As Heidi said, they've been requested for so long. And in fact, when we had SQL CLR code first came in 2005, the number one use case people were using that for was to build regex. And so the fact that that's now native in the database engine is a wonderful thing. For AI-powered query authoring, we've got GitHub Copilot. And for the database operations, the MCP Server Data API Builder and role-based access control. And so look, preparing for this exam, when this is coming up, you clearly need to review the study guide. It's quite a sizable study guide for this particular exam. What I would suggest you need to do, as you do with any of these exams, you need to step through every single line of that study guide and ask yourself seriously if you understand the topic. If not, get out and try it. Importantly, you need to do hands-on work with this. There are many preparation resources already there. Make sure you work through all of the Microsoft Learn modules. There are a lot for this. There isn't a practice assessment last time I looked yet, but when it is, make sure you take that and, of course, schedule your exam. So Heidi, 60 days of data and AI.
Yes, we're back. We're towards the end. It's a quick hour there with 60 days of data and AI, but I saw a lot of comments in the chat around study groups and groups around the world. So this doesn't stop here with the 60 days. It's just a focus 60 days for DP-800 where we're focusing on getting you prepared to work for that exam. Now, don't stop there. Go take the exam. Take all of the exams. Take whichever ones you like. There's a cool one on Azure Data Fundamentals. That's a good precursor to get you those basic fundamentals of working with data and then transition into that DP-800. And as Greg said, make sure you look at that study guide because it's got your prerequisites that you need as well in case there's another exam as an entry to that one. And then make sure you can retry the exam. So if you fail, don't worry. This does happen. I know I failed a number of times, but I don't let that stop me because when I do finish the exam, it's either instant gratification with the yes, you've passed, or it's instant disappointment with no, you failed. But it also gives you
one of the downsides I find when I do the beta exams is just that waiting period between when you do it and when you get the result. Yeah,
but you just give it another go. So if you take the exam and you don't pass it first time, that's okay because it'll give you some tips on where you can study further, which sections you might need to do better. It's not going to tell you what you get right or wrong, just the sections and how you went. And then make sure, you get out there and talk to the community and ask questions. And I know our moderators have done an absolutely fabulous job today. So thank you, team. And our producers as well and the Microsoft staff for making this happen. And make sure you submit the survey so you can have more sessions like this. We want to know what you want and what we can help you with. And of course, couldn't have done it without you, Greg. Always love the insights you share. And I'm always learning a lot when we present.
Oh, good. Hey, so listen, thanks, Heidi. Thank you, Molly and Pam.
And thanks, everyone in the chat.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.